Hello again. Recently, there was a dwarf planet in our solar system out sort of Pluto-ish and beyond, where they've discovered that it has an atmosphere. And so we'll talk about dwarf planets and the ones that have atmospheres that we know of so far. So the dwarf planet classification. There are objects in our solar system like Ceres and Pluto that are not classified as full-fledged planets. They are dwarf planets. The term dwarf has nothing to do with their size. It has to do with one particular aspect of them. They orbit the sun, just like other planets do. They're sufficiently large enough for hydrostatic equilibrium to make the celestial body roughly spherical. And if you think Earth is a perfect sphere, no, Earth is kind of squished at the top and bottom due to its rotational speed. It's called an oblate spheroid. And dwarf planets are not natural satellites of another planet. They're not a moon. But dwarf planets orbit the sun within a debris field, the asteroid belt, the Kuiper belt, or the Oort cloud. And so that's how they distinguish them as they can be like a planet, but regardless of their size, if they are orbiting the sun within a debris field, they're a dwarf planet, not a real planet. The number of dwarf planets is now at 35 plus. They're finding more all the time. Somehow they found it intolerable to have to know about all 35 of them and growing in middle school and high school. So they just classify them as dwarf planets. You need to know about the 8, but that's all you need to know about when you're going through school. However, over in chemistry class, there are now, I've been told, 118 elements in the periodic table of elements. Oh, but you're going to need to know about all those. So as they fill more in the table, the students in the following year's class are just expected to know more. In the last couple of years, I was off. I knew when they went to 115, but I didn't know they went to 118. And also, Jupiter and the Earth do have other asteroid-like objects in the orbit with them around the sun. These are referred to as Jupiter's Trojan asteroids. Earth has its own about 50 or so Earth in the same orbit asteroids. It has been postulated that there is a planet out in the Kuiper belt or maybe out as far as the Oort cloud that is in that debris field, but is noticeably larger than the Earth. And for it to be that size out that far where it's cold, it's probably another gas giant, but that's just postulation. We don't have the evidence yet. So it turns out there's this cycle of types of planets around a star. So we have the inner planets, Mercury, Venus, Earth, Mars, and those are rocky planets, terrestrial planets. And then you go out further and you find gaseous giants, Jupiter, Saturn, Uranus, and Neptune. It turns out that if you go farther, that these dwarf planets, starting with Pluto, are once again terrestrial-like. They're not gas giants anymore. They're smaller and they have kind of a rocky construction. They may have liquid on the surface that gets frozen. Turns out that those dwarf planets seem to have atmospheres. So far, none of the gas compositions, pressures, or temperatures would support life as we know it. They're too far out there, too cold, and they don't have sufficient oxygen. They have nitrogen, they have CO2, methane, no oxygen, not a sufficient predominant quantity of oxygen where life as we know it could exist. And the pressures are very thin. The thickness of the atmospheres is very thin. And the elliptical picture you see at the bottom is of Sedna. And the bullseye circles on the left, that's where the rest of the solar system is. And then you see Sedna has a very elongated orbit. If it did have an atmosphere on Sedna, being that far away from the sun, it's likely that its atmosphere will be frozen to the surface. So how is it we detect atmospheres around these dwarf planets? And as long as you have a source of electromagnetic radiation, light, various wavelengths, if you want to see things in the asteroid belt, you wait until they're kind of opposing the sun so you can get some light on them, and then you take the light coming back and you analyze it, and you can determine atmospheric composition and such. Or you can send probes like we did to Ceres out in the asteroid belt, and they can observe the sun's light through the thin atmosphere and do their own spectroscopic analysis. In the case of New Horizons, when it was slinging around Pluto, as it came out the backside, it directed a radio transmission towards Earth, and the transmission went through what would be the atmospheric layer of Pluto. And when the Earth received that signal, they could do analysis on the received radio spectra and determine the thickness of the atmosphere and the composition of it and the pressure and the temperature. If you have a light source and you run that through an atmosphere and you know what the light source's spectral qualities are, you can take the resulting electromagnetic radiation that you receive and subtract out the source. And now you know what's being emitted. And if you look at the spectral lines, you can see the emission and the absorption. And the absorption will tell you the chemical composition of it. And the emission will tell you what it's radiating, what energies are there. So it turns out we've discovered through Hubble, the Hubble Space Telescope, that there is a dwarf planet that has an orbit that is more circular than Pluto, but it's out farther than the average distance of Pluto. So it's more often than not nearer than Pluto is, but sometimes Pluto is nearer than it is as part of the orbit. And we found that if you go and look at that object and you have the light coming from it and you break it apart as a spectra, you can find that this thing seems to have an atmosphere. And if you allow it to be occulted, has nothing to do with mystical arts, you have something bright pass behind it, like a distant star, you can take the spectra of the distant star, and as it goes behind the dwarf planet, it will add in its spectral characteristics, and then you can subtract the stars out, and now you can see atmospheric characteristics of this dwarf planet in our solar system. Turns out this particular object, catalog ID 612533, it was discovered in 2002. In 2002, it was XV93. Rolls trippingly off the tongue. I couldn't find like a human anagram name for it or something of that nature, but I'll just call it XV93. That's Roman numeral, XV93. So they found out it has an atmosphere. It's a very thin atmosphere, but it seems to always be there. And given that it's about 5 astronomical units beyond where Pluto is on average, and an astronomical unit is about 93 million miles, so 5 times 93 million miles farther than Pluto, then the atmosphere of XV93 should always be frozen to its surface. It's so far from the heat of the sun. Turns out it's gaseous. And the only way it can maintain a gaseous atmosphere that far from the sun is if it has a local source of heat to keep the atmosphere from freezing out. They have no clue what the heat source is, whether it's volcanic or something even more bizarre, like that's actually an extraterrestrial outpost and that's their nighttime light pollution. But who knows? The only way we're going to find out more is keep observing. And if you look at the picture at the bottom, you can actually see the pixels, little square dots, white and dark, light and dark, gray dots. That's the resolution, which means we have no ability currently with our current instruments to resolve it any better. So we don't really know how far out the atmosphere goes. We have an approximation. How bright is it versus the brightness of whatever's making the atmosphere stay gaseous? We need something that gets much higher resolution of dwarf planets in our solar system. Who knows? Maybe the Roman telescope, which is going to be launched in September, might have better resolution to look at this. So in summary, dwarf planets might be dwarf in size. They might be within a debris field, but they can have characteristics of regular planets, like atmospheres. If you're out in the Kuiper belt of the Oort cloud, the presumption was that the atmosphere would be frozen to the surface. Turns out that's not the case for something even farther out than Pluto. So we have observations that can now go out further and further. As we find more things out there, we're going to find more of them that have atmospheres. What is keeping the atmosphere gaseous is a big question to answer. Keep looking. You never know what you're going to find that has always been out there, yet unseen. And some links like, what is a dwarf planet? Tell me about Pluto and the atmosphere of it. And then the atmosphere detected on XV93. Comments? Questions? I knowingly did it as a short one today because I noticed that the one from last week had a lot of views, and I wanted to see if it was because it was short. The fact that there are dwarf planets in the outer part of the solar system that have gaseous atmospheres despite the bone-chilling cold, as they say, that far out, says something's got to be heating up. If it's not like the moon Io, where you have gravitational forces expanding and compressing it and keeping its core molten, if it's that far out, volcanism, volcanoes are the only thing that's going to be hot enough in the core of a dwarf planet to keep its keep its atmosphere gaseous. Any comments or questions before I stop recording? Hearing nothing.